Well, let's be clear. The very first life was nothing like you and I would think of as life. To make matters more difficult, it's almost impossible to detect it today in any fossilized form. So where on earth do we begin? Well, we do know we had the basic chemical elements on the early Earth made from the exploding stars. And we know that life did come to exist at that time, as we have evidence to prove that. We are therefore simply looking at filling in the gaps. So we are looking for a process that was a stepwise transition from simple chemistry to more complex chemistry and to biology. We also know through experiment that if you take the atmosphere of the early Earth and some basic elements, charge electricity like lightning through it, you can create simple organic molecules such as amino acids. Volcanic vents in the deep sea also produce these basic building blocks of life. And it turns out that these biomolecules even get created in space. We also know that whenever the basic building blocks are around, if you add an energy source and more elements, you often get greater and greater complexity. Carbon happens to be the most likely element for life, as it links in lots of interesting ways to most other elements. It almost can't stop itself. With abundant carbon-rich material, liquid water and diverse sources of energy, the early Earth seems to have taken less than 1 billion years to produce the very first life forms. But we are some way from understanding the exact way that this complexity increased. Just organizing one protein, such as collagen, with 1055 amino acids in exactly the right sequence, is like winning the slot machine with 1055 spinning wheels instead of the usual 3 or 4. And this is just one of the many proteins that are needed for life today. And even if we can beat these impossible odds, how does it replicate itself? For that, we need another complex molecule, like DNA, that can reassemble more of these proteins in exactly the right sequence. And to make matters even more against these events happening, how did all the proteins and the DNA get held together in a membrane to protect them in? It's simply impossible to have these events happen in a one-off event. Millions of spinning wheels all needing to sequence correctly. But what if we could just work on one of the wheels on the slot machine? The chances of getting this right are much better. And once we get it right, we then have a lot of time and chances to get the next one right. And the next one, and so on and so on. And suddenly, the improbable large step with the amount of time and space, amino acids and energy available on the Earth becomes the probable sequence of very little steps. We have some excellent but as yet unproven ideas on how this may have happened. There are many chemical cycles that add complexity and energy continuously. Each step adds more organic molecules into the mix. An example of this is the reverse citric cycle, which is a candidate for how we moved from very simple chemistry to more complex chemistry and eventually to biology. It is possible that this build-up of complexity was somehow copied onto a mineral surface, such as clay or silicon, and was able somehow to copy itself and slowly make life-giving elements. Another candidate is the copying mechanism itself. Templates formed on clay and silicon can make numerous exact copies of themselves. If we add an energy source to these templates of organic material, we start a process that could have led to the first life. Now, this is particularly appealing because of the ancient role of RNA as a copying mechanism. Interestingly, primitive lipids or fats are often produced under natural chemical conditions and can spontaneously form a water encasing membrane, as one side is water-loving and the other side water-hating, to fulfill another essential step of creating a cell protective membrane. Or maybe it is a mixture of all these theories. The incredible complexity of what was needed to happen was an incredible chance event, bringing together chemical cycles, lipids, and template-forming structures with accessible energy and water to make an organic molecule that could somehow replicate itself. Given the speed that life developed, these events may well have taken place on a planet outside of the Earth. We are some way away from a full understanding of how all these complex events came together, but we are well on track to prove some of these basic theories. There is little doubt, however, that life has to organize itself, using some method to survive. Get it wrong and you die. Amazingly, every single one of your ancestors, down from these very first complex molecules over 3.5 billion years ago, got it right. Living things also have to have a period of stability, and within that period they use energy from their surroundings to maintain their complexity. The energy is then used to make self-copies, and over time, because of the instability of the replicating process, these copies are prone to change. And this provides the necessary means for adaptation, and our very next topic, evolution.